All right, physics fam, we are doing some extra practice with free body diagrams in that. If we read it, you've got 150 Newton force is applied to a 25 kilogram book. So let's keep that in our minds that we've got a 25 kilogram object here. And it's accelerating at 4.5 meters per second squared on a table. Okay, so if we have an applied force, let's put applied force to the right. And that applied force we know is 150 newtons. Okay. We know also that it's accelerating at 4.5 meters per second squared. Since this object is going left to right, that's in the x direction. So we know that the acceleration is 4.5 meters per second squared. Now, since this object's probably on the ground being pushed or on a table or something like that. Oh, and that's what it says. Yeah, it's on a table. That means that the up and down forces are probably equaled out. And those two forces would be the force of gravity and the normal force. Now, since those will cancel out, that means the net force in the y direction would be 0 newtons. And if there's no net force in the y direction, there can be no acceleration. So for these problems, you'll never have x and y have both of an acceleration. We're only looking at in one plane them working and moving. So right now we're going to focus on the x plane. So we're assuming that it's definitely accelerating. And since it's accelerating to the right, we can assume that there is a force of friction going to the left, opposing it. So now that we've drawn our free body diagram, we want to make sure we get the newtons of force for each of them and figure out that overall net force too. Okay, where do you want to begin? We can start a lot of places. Let's start with the net force in the x direction. Okay, that's the same thing as net force is equal to mass times acceleration. Do we know the net force? No. Do we know the mass? Yes. 25 newtons, 25 kilograms. And our acceleration here is 4.5 meters per second squared. And we're assuming that to the right is positive. So when we multiply those together, we end up getting 112.5 newtons is the overall net force in the x direction. So we can add that to our mix. Now that those are taken care of, let's just figure out what all of our different forces are going to be. Well, since we just worked in the x direction, let's finish that out. The net force is not only equal to mass times acceleration, but in this case, the net force in the x direction is also going to be equal to you adding up your applied force and your force of friction. Sorry, that's an equal sign. All right, do we know anything? Yeah, we know that the net force is 112.5 newtons. We know that the applied force from up above is 150. We just have no idea what the force of friction is. But if you subtract 150 to the other side, you end up with a negative number of negative 37.5 newtons. And that's exactly what the force of friction would be. 37.5 newtons to the left, which we would say is negative. So now that we solved for that, we still have to worry about the force of gravity and the normal force. But we know if we know one of them, we know the other. They're going to be equal to each other. And lucky for us, we know that the force of gravity is the same thing as weight. And that weight is just equal to mass times the acceleration of gravity. So if we want to solve for weight, let's just plug in our mass of 25 and multiply it by the acceleration of gravity. So we get 25 times negative 9.8, what ends up equaling negative 245 newtons. All right, so that means our force of gravity equals negative 245 newtons. And because they're not accelerating in the y direction, the vertical plane, then the normal force would be able to assume that that is 245 newtons up. Now, we've drawn the free body diagram, all the forces, found the values of all of them, and all the acceleration and net forces in both the x and the y direction. Good to go. For question number 2, a 29 kilogram bird, which that is my mass, that's good to know, is falling at 2.5 meters per second squared. So if you're falling, that's in the y direction or the vertical direction. So that means that bird is falling at 2.5 meters per second squared. And if it's falling, and it's probably speeding up, that should be a negative 2.5 meters per second squared. Now it says to consider air resistance as well. So any object falling is under the influence of the force of gravity, and then vice versa, the air resistance as well. Now since this animal is just falling, there's nothing to the left or right. So that means in the x direction, there's no net force or acceleration, which is nice. We knocked out quite a bit already. All right, so then we just need to figure out the net force and also the force of gravity and the force of air resistance. Where to begin? Well, we can do a couple things. We can figure out the net force because we know that the net force, specifically this in the y direction, is equal to the mass times the acceleration of the object in the y direction, don't forget, but we assume that. We already wrote it here. So F equals ma. To plug it in, our net force equals the mass of the object, which is 29 kilograms, times the acceleration of negative 2.5. We did negative acceleration because we're assuming it's speeding up as it's falling down. And remember, if the object's falling and velocity is down, acceleration should be down too, so that should be a negative value. Multiply those two numbers together and you get negative 72.5 newtons. So good. We've got our net force now in the y direction, which means overwhelmingly the net force is in the downward direction. Okay, so we can use that eventually because the net force in the y direction is really just going to be the two forces added up, the air resistance plus the force of gravity. Now, once we get the force of gravity, and we already know the net force in the y direction, we can then solve for air resistance. But we don't have force of gravity yet, so let's get that off to the side. Now, I know that the force of gravity is equal to the weight. It's the same thing. And I know that weight is equal to mass times gravity. So, if I want to solve for weight, I just put in my mass of 29. My acceleration of gravity is negative 9.8. Multiply those together, and I should have my force of gravity, which ends up equaling negative 284.2 newtons. All right, so if that's my force of gravity going down, let me put that in, negative 284.2 newtons. All right, now that I have that, I can plug that in to my equation over here, and I have my net force I can plug in right there, and I can solve for air resistance now. So let's do that. So my net force in the y direction is negative 72.5. My air resistance I don't know, so I'm leaving that as a variable, but my weight or force of gravity is negative 284.2 newtons. Now add positive 284.2 newtons to the other side, and you end up getting a positive number that would be equal to positive 211.7 newtons. Now the reason it's positive is because this force is in the upward direction. So that makes sense. Where's the overall net force? It's still downwards because the force of gravity is greater than the force of air resistance. So acceleration is downwards, so is the overall net force. And we know that according to Newton's second law, these two guys are always in the same direction. All right, so that concludes problem number 2.